Hello, welcome guys. We're going to go over some information about the rate of reaction formula and how to calculate it, and kind of explain a little further about collision theory in chemical reactions. I am hoping that each day you guys are watching the Watch Me First video clip. Hopefully you're doing that. It should appear in the stream. Today, we're also going to have a survey form where you guys can give me some feedback and maybe tell me other types of activities that you would like to do. I would like to mention that earlier in the stream, I had posted how to get a Chrome extension to read aloud. So if you're having difficulty reading a lot of websites, you may want to scroll back and see how to add that Chrome extension, especially if you're doing it for English or social studies or something like that, where there's a tremendous amount of reading from websites. You might want to add that Chrome extension so you could read aloud. Lots of good hints in the little stream portion that I've been posting all along. If you have any questions, you can certainly add a little comment to any of our posts and ask your classmates or email me. I will be happy to direct you. Today we're going to be talking about the rate of reaction. And what we're going to be talking about is how reactants, those are the substances that are there first, they're usually listed on the left side of the equation arrow, are converted into products. Those are the substances that exist after the reaction. They're listed on the right-hand side of the product. Another way to think of rate of reaction is the speed that reaction is happening. How fast is it happening? The rate equation measures the amount of change over a period of time. Some common examples of rate you may think of in track, where it's the change in distance over a period of time, or perhaps even a speed limit sign, where they're measured in miles per hour or kilometers per hour. In chemical reaction, the rates can be characterized as very fast, like a firework exploding or a match burning, or very slow, like the time it takes for coal to form or a baby to become an adult, or maybe something to rust, or something that's moderate, like the time that it takes for food to spoil or a tomato plant to grow. We're going to be using some diagrams, and here we're showing the reaction where the red squares are the reactants and they are forming the blue circles. As time passes, the amount of reactants, the red squares, decrease, and the amount of product, the blue squares, increase. We can actually measure a rate of reaction as the change in the number of moles, or possibly the number of grams or milliliters, or a thing called molarity of the reactants or the products over a given period of time. When you interpret these diagrams, you may have to make some assumptions, like think of these blocks as each being equal to 5 seconds between the boxes. Is the rate of reaction constant throughout? Does it look like it's a linear relationship or it's nonlinear? We're also going to be able to calculate the rate of reactions. There are 2 example problems on the bottom, but we're going to work on this one on the top. You should try those other example problems on your own in your own notes or a scrap piece of paper. The example problem says, in a 45-second period, the amount of gas increases from 5 moles to 18 moles. Calculate the rate of reaction. So what we're going to do is we're going to take the change in concentration, that's the difference between the 5 and the 18 moles, and we're going to calculate the rate of reaction by dividing by the 45 seconds. So when I set that up, it looks sort of like this. 18 moles minus the 5 moles is equal to 13 moles. I'm going to divide that by the 45 seconds, and I will get a rate of 0.29 moles per second. Try the 2 problems on the bottom on your own. There is a video link here. If you look up here where it says watch me, you can go ahead and click that video link to review collision theory. There are 4 aspects of collision theory that you should represent in your model in assignment 4, and you should have been talking about the explanation and the rate change in assignment 3. First, in order for a reaction to occur, atoms have to collide with one another. Second, the atoms need to have enough kinetic energy or speed when colliding for a reaction to occur. If they don't have enough energy, the atoms bounce off of each other unchanged. Third, the atoms need to be facing in the right direction. They need to have a correct orientation. Fourth, the colliding atoms must have enough energy to break the bonds and then form new bonds. When atoms collide, the minimum energy needed for the reaction to occur is called activation energy. In fact, when you use a catalyst, one of the main things that a catalyst does is it speeds up a reaction by reducing the activation energy, and it does this by helping to facilitate that facing the right direction and orientation so that the bonds can be broken and new bonds can be formed at a lower kinetic energy. A visual picture of the collision theory is summarized here. The reactants are moving too slowly, they bounce off of each other, no reaction. The reactants are not facing the right way because they're not orientated correctly, they bounce off, no reaction. And lastly, if the reactants have enough energy and are orientated correctly, you do get the bonds breaking and new bonds forming, a chemical reaction occurs. Another visual here kind of points out those 4 steps in a little bit more pictorial way. Atoms collide, the bonds break, atoms rearrange, new bonds form. We're going to start looking at these potential energy diagrams. These potential energy diagrams show the energy of the reactants. They show where the activation energy is and the atoms collide. When those atoms collide, they're at this peak right here, the activated complex. That's where the bonds are breaking and the atoms are reforming. And then they come down the potential energy and the energy of the products are lower. In this type of arrangement, the reactants are higher than the products, and this excess portion right here is energy released. And we're going to start talking about exothermic reactions, where the energy is released and exits, and endothermic reaction, where we actually require energy in order for the reaction to occur. Again, right now we're talking about kinetic molecular theory, collision theory, rates of reaction, and we're going to get involved in potential energy diagrams as this unit progresses. So for today's class, I'm going to ask you to kind of update your model that you made for assignment 4. Make sure you've included information about kinetic molecular theory, collision theory. Start thinking on the particulate level. I'd like to see some diagrams where we have molecules and atoms drawn. What I would like you to do is to post your model to your class Padlet. If you go to the stream in Google Classroom, there'll be a link for the Padlet. When you get to the Padlet, you're going to go ahead and click this little plus in the bottom corner and upload your diagram. Take a moment to look at your own model in relationship to other ones that are posted. Go ahead and edit your model. Continue to add to and update your model during this entire unit. When you post something on here, it's sort of like a gallery walk. I want you to look at the other students' materials. Go ahead and add some to yours. You can always go back and delete yours or add a new one if you've updated it a little bit more. I tried not to give away too much of the information because I'd like you guys to be brainstorming and thinking of this yourself. I did write a chemical formula here so you could use that if it helps you. Again, you need to upload your model to assignment number 4 in Google Classroom as an individual, but I would like you all to kind of share and brainstorm your thoughts on the Padlet so that we can get as much information as a class collaboratively. And finally today, I'd like you guys to finish off this survey on the Google form. You could click here if you would like. I'm also going to attach it in the assignments. It will not be numbered, but I would like each person to go ahead and fill these out so I can get an idea how things are going and what types of activities that we should do. Again, you know you're finished for the day when you've submitted your daily attendance. You've completed assignment 3 and 4. Upload 3 or turn in to the Google Classroom. Same thing with the individual model for assignment 4. In assignment 4, you also want to add it to the class Padlet. You do want to take a look at all of the assignment 4s on the Padlet. Think of ways to update your own model and start on those updates, and then finally finish the Google form survey. Thank you guys. I miss you very much, and I hope things are going well, and we can talk soon. Email me if you have any individual questions.